Hi everybody, so this is going to be a recorded session tonight. Hopefully lots of you have been after school working on your coursework, so it's a bit much to ask you to then rush home and do a live session. So this is just a recording, and I'm going to start by going over some of the common mistakes that students made in their mock exam. And this section tonight is just going to cover a couple of those. Now this is linked to some flashcards I've made for you. So I've mocked up some flashcards. They've got information on them, but they have got spaces that you need to add to them, so they are interactive. So you do need to check your emails. You need to pull the flashcards off your emails, and you need to have those to be working on as well at the same time. Obviously, with this being a recording, you can watch it back as many times as you want to. You can pause it. You've got the beauty of that for it as well. Okay. So the first thing that lots of people did wrong was not even attempting the question. Lots and lots of exam papers had questions that were just blank. And we have covered everything that you are being asked for in these mock exams. So some of it might have been all the way back at the start of year 10. It might be really digging deep to try and remember some of those things. But we have covered everything. So you should have a little bit of knowledge about everything that's on that exam paper. And even if you are sat there pulling an absolute blank and you cannot remember anything about that particular topic, have a guess. Just have a guess, have a go. Have as educated guess as you can on the topic and the question, because you never know where you are going to get a mark. Some of you missed out by the next grade by 1 mark. If you'd have had a go at that question, you might have picked up 1 mark for it. So you absolutely just have a go at every single question. Now, by all means, go through your exam paper, answer all the questions that you're confident at first, then go back and answer the questions that you're not so confident at, where there's a lower chance that you're going to get marks on them, so that you've secured all those marks that you're confident at first. Cheap. Lots and lots of answers about materials being cheap, and the reason they're more suitable is they're cheap, and the properties of that material is that they are cheap. Now, the mark scheme for most of these types of questions says do not accept cheap. Okay, so please try not to put cheap as a reason for one of the properties of a material, or the reason why a material has been used for something, because you are not likely to get the marks for it. That leads me on to properties. So there's a list of properties that you need to learn, and you need to be able to recognise which materials have which properties. Okay, so you absolutely need to remember these, and these are the first things that I've got on the flashcards for you. So these are just example of 4 of them. So stiffness, for example, stiffness is the ability of a material to resist bending. Okay, and in part it's relation to the strength of the material. The stronger it is, the more it resists deforming, the stiffer it is. Then I've put a space there for an example. So that's where I want you to think of an example of a material that has a lot of stiffness to it, and a particular stiff material really resists bending, and put an example there for me. So just to give you a little bit of the clue, paper is not a stiff material because it bends really, really easily. So lots of metals are quite stiff because they are not easy to bend, but try and think of a really good example for a material that's got a lot of stiffness to it. Okay, and you need to work your way through these properties, learning them, and be able to have an example for each one to show a material that has that particular property. Okay, another areas where people seem to struggle is polymers. So polymers is another word for plastics. Polymers and plastics are split into 2 main groups. They are either a thermoplastic or a thermosetting plastic. And the clue is in the name there. Remember that setting bit of it. That gives you a real big clue to the properties of those particular materials. So thermoplastics, most plastics that you come into contact with day to day will fit into this group. And what a thermoplastic means is when the plastic cools, the bonds reform and the plastic will retain its new shape. Now that's quite wordy, so what does that actually mean? Well, it means that the plastic can be melted and remoulded over and over again. So these are the plastics that can be recycled. So they are your everyday plastics that you use. You use them, they can be recycled, they can be melted down, and they can be made into something else again. Okay? They are your slightly more environmentally friendly plastics than your thermosetting plastic, but obviously plastics still aren't a great material to use because of where they come from, which is where, have a little think, they come from oil, which is a fossil fuel which is non-renewable. So when we run out of oil, we're going to run out of new plastic. So it is really important that we do recycle our plastics and make sure that we are trying to use thermoplastics for wherever we can. However, we do need thermosetting plastics for some things. Again, here, look, the clue is in the name, thermosetting. So they are set. Once they are moulded, they are set in place. So these plastics, when they're formed, they cannot be reheated and moulded again. If you try and heat them up, they'll just burn really nastily. They won't do anything. They're just completely not usable. This, however, makes these plastics really heat resistant, and we do have applications for that. So we do need plastics that are really heat resistant. We do need casings for things where they're going to be subject to a lot of heat or chemicals, and we do have a need for them, but that means that they cannot be recycled. So you've got quite a long list of thermoplastics that you need to learn, and the list is there. You need to learn these plastics, their uses and their properties. Now that does sound quite, oh my god, how am I going to learn all of these? There's loads there. But once you start to look at plastics in a bit more depth when you're using them, rather than just using it and not thinking about it, when you start paying attention to them a little bit more, it will become easier and easier to learn. Again, I've made you some flashcards. So on there, you've got the title at the top. So PVC, for example, I've put PVC there, then I've put P and left a space. So in that gap, you would need to fill in polyvinyl chloride. I've given you the properties, and here you can see that those properties relate back to the properties cards that we've talked about earlier. So it's got stiffness, it's hard, it's tough, it's got good chemical and weather resistant, and there's a space there for you to write the uses of PVC. Same again for the other ones. There's one of these for every one of those thermoplastics on the list. So thermosetting plastics, these are the ones that you've perhaps not heard of as much. So the other ones, you've probably heard of PVC, you've probably heard of polypropylene, probably heard of acrylic. These are the ones that you perhaps haven't heard of. And these are your thermosetting plastics. And again, you need to learn about these, their uses and their properties. Again, you've got the flashcards there, you've got your properties there, and you've got your space for your uses. So polyester resin, it's got good strength and stiffness, but it's brittle. Very good temperature, chemical and electrical resistance. What is it used for? That's what I want you to find out. So the next area that people struggled with is all to do with metals and treating metals, heat treatment of metals. So metals are made up of lots of grains of material pressed together. If you put them under a microscope, the picture on the right is pretty much what you'd see, depending on the metal. Okay. Now, the size and the shape of these grains affect the properties of the metal. So in general, as the grain sizes reduce, the metal becomes really hard and strong. But it becomes less ductile and becomes more brittle. And you can change the grain size by either cold working it or heat treating it. So cold working is where we're not using any heat. So we might be working on it with a hammer, we might be working on it at the lathe or in the milling machine, and it's the material, the metal is taking an impact. And most metals get harder as work is done to them. And this is known as work hardening. So if I've got a piece of steel and I'm hitting it with a hammer, I might be shaping it, I might be trying to bend it or something. The more I'm doing that, the more harder it's going to get. It's going to become work hardened. It's going to get to a point where I can't do anything with it. And this is when it might get brittle and break. When a metal is cold worked, the grains are affected and they're really deformed, and it makes them stretched out, making the grains thinner and smaller. So that metal's got really, really hard. It becomes difficult to work with. There's things we can do about that. and we can do lots of different heat treatments, and the different heat treatments depend upon the metal and depends upon what you want the outcome to be. So if you heat your metal to a suitable temperature, the grains can grow within it. So your grains will get bigger, they'll get more spread out, and it makes the metal softer and much easier to work with. Okay, process called annealing is used to soften metal that's been work hardened and to make metals easier to bend into complicated shapes. So you might have seen people on the forge before where they heat the metal up and then they're bashing it around the anvil and they're shaping it and they're shaping it and they're shaping it and bashing it. Then they heat it up again and they bash it and they bash it and they bash it and bash it. Then they heat it up again. Okay, that is heat treatment because you're heating it up, the grains are expanding, you're working it, so you're work hardening it, and then you need to heat it up again to release those grains to make it so that you can move the metal around again. So hardening. Hardening is for steel. It's a heat treatment that just changes the arrangements of the atom, making it harder and stronger. So you heat it up, there's a little animation of that there. You quench it, which means you're cooling it rapidly. Okay, so you're popping it in some water and you're cooling it rapidly. So you might have done this if you have used the welding or used the forge. You heat it up and then you quench it because you're cooling it rapidly. And you can quench in water or you can quench into oil. Normalising is a process which is carried out on steel which has been work hardened. So it involves heating the steel just above its upper critical point. And the critical point is the point at which it's going to deform. Then you allow it to cool naturally in the air. So we're not rapidly cooling it here. We're not quenching it when we're normalising. We're just heating it up and letting it cool in the air. And what that does is it allows all the atoms or the grains to rearrange within existing grain, and that relieves any internal stresses. Okay, and it results in steel which is tough but has a bit of ductility to it, so it can be worked. Annealing, so we talked about annealing a little bit. Involves heating the metal to a suitable temperature. You hold it at that temperature for a bit of time, and then it allows the grains of the metal to grow, making it softer and easier to work with, relieving internal stresses, allows dislocations to relocate to the grade boundaries, and it's used to soften metals that's been worked harder or to make metals easier to bend into complicated shapes. Now, annealing can be used on both ferrous and non-ferrous metals. Annealing is a term that's used for lots and lots of different metals. So you can anneal steel, you can anneal silver, you can anneal copper. In jewellery making, you'll do a lot of annealing because if you were making a gold ring, for example, you would have to heat that up, you'd be working it round, you'd get to a point where it's not working anymore, you'd re-anneal it, heat it up, bend it round, and it's a process of keep doing it. It's not sort of I'm just going to anneal it once and it'll be done. It's a process. So steel, when we're annealing steel, it's heated to just below the critical point, which is about 700 degrees, so it's pretty hot. Then it soaks in that temperature for a period of time, so that just means it sits at that temperature for a period of time. And the duration will depend on the size of the part. And then it's slowly cooled by just leaving it in the furnace. Aluminium alloys are often annealed after working with them, so they have to be heated to about 300 to 400 degrees. You have to be really careful with aluminium because its melting point is about 660 degrees. Heat it up to that, it's just going to melt. Copper is really easy to anneal. It's heated to a dull red colour, so you can see that colour on the right hand side there. That can either be cooled in water or left to cool in air. And black scale, that might form on the surface due to corrosion, and you can clean that off by putting the copper into a bath of dilute acid. So that's known as pickling, and that just cleans the surface of it off. So jewellery making, you do pickling quite a lot in jewellery making. So you would pickle gold, you pickle silver, and that's because when you've heated it up, you lose that brightness of the material, you lose that niceness, and you get black scale on it, but the acid will take all of that off. Brass can also be annealed to heat into a dull red colour, but it is quite brittle at that temperature, so it has to be cooled slowly, and again it has to be pickled to remove black scale. Tempering, again, you can temper different metals, and it removes some of the brittleness in a hardened steel. So once you've finished making something, you might want to temper it, and you can see there that colour chart. So at the toughest, you're heating it to a blue colour. At the hardest, you're heating it to that light straw colour, and it depends on what your application is as to how you want to temper your metal. And you do that once you've finished making your product. Now, one other thing you might want to do is to add carbon to your steel. So carbon is very, very hard. And some products remind the toughness of low carbon steel, but with the high hardness of high carbon steel. So they need to be made from low carbon steel because they need to be made from that to be manufactured, but they need some real hardness in them to be made of high carbon steel. So gears in train engines need to be tough so they don't fracture because of the pressure put on them. We don't want them to crack and break. But they also need to be hard so they don't wear out where the teeth touch. Because if those teeth wear out on the edge, then the gears won't mesh together properly. So you can do this by manufacturing them from a tough low carbon steel. Then you increase the carbon just on the surface by producing a hard skin that resists wear. And this is called case hardening. So processes, the steel's heated to red. You might, depending on what you're doing, you might only need to harden one end of it, or you might need to case harden the whole thing. So you heat the area that's needed to be done. You remove it, make sure you're doing it carefully, making sure you're using your tongs, and you're putting it in hardening compound, which is high in carbon. Okay, you then have to heat it again, and then you plunge it into cold, clean water. So you're quenching it in cold, clean water. And it now should have a nice hardened outer surface and a flexible, soft interior. And you can keep doing this to increase the depth of the hardened surface. You can keep adding layers onto that. And the last thing I'm going to talk to you today about is about energy sources. So you need to be able to understand the bigger picture of design. So you need to understand a bit more about, we're not just designing and making stuff, but we're thinking about where does it come from? Where does the power come from to make this? What's the big picture of what's going to happen to my product? How does it affect the environment? What's going to happen to it after I've used it? And power sources is one of the things that you need to know about. Now, power sources fall into two categories. They can be non-renewable, which are your fossil fuels, your coal, your gas, or your oil, and they can be renewable, which is your solar, wind, tidal, and biomass. And in your exam, you need to be able to discuss the different fuel types and compare them to each other, thinking about the advantages and disadvantages and the impact of the fuels on the environment. Now, generally, this was done not too badly in your exam. Generally, people know quite a bit about fossil fuels. Generally, people know quite a bit about solar power or wind power, for example. But biomass is one of the ones that people aren't really sure about what it is, how it works. And tidal was another one where people weren't really sure about. So follow this link. This takes you to a technology student webpage. Lots and lots of links on this page. There's more than what you need. You need to scroll down a little bit and it talks about fossil fuels. So you can click on those links and it gives you a bit of information about fossil fuels. Scroll down a little bit more and it talks a little bit about renewable energy. So have a look at that. And again, go back to your flashcards and fill in the information on your flashcards. I hope that's been helpful for you. It's only a quick recording because you have work to do with that, with your flashcards. So what you need to do now is go on your email, download those flashcards. You can print them out and you can write on them. You can add text boxes to them and write on them as well. It's up to you how you want to do them. And you need to spend the rest of your little bit of revision session just working on those flashcards. As we go, we will keep building up these flashcards so that hopefully by your exam, which is on the 20th of June, you will have a nice big pack of flashcards and you'll find it quite easy to revise. As ever, if you've got any questions, please see your teacher, see them in lesson, email them, pop in and see them, and we can help you with anything that you need. Okay, thank you for listening.